Alright guys, today's goal, the learner will understand how to graph quadratic inequalities. So let's read through this. The graph of a quadratic inequality is one of the forms above. Follow these steps. Step 1. Graph the parabola with the equation y equals ax squared plus bx plus c. Make the parabola dashed for inequalities with less than or greater than, and solid for inequalities with less than or equal to or greater than or equal to. Step 2. Test a point xy inside of the parabola to determine whether the point of the solution of the inequality. So when you test it, is it true or false? Step 3. Shade the region inside the parabola if the point from step 2 is a solution, meaning true. Shade the region outside if it is not. Okay. So step 1. Well, look, dashed or solid. This is going to be dashed. Now it says set it equal, so change it to y equals negative x squared minus 5x plus 1. Well, and then set it equal to 0, and we have to factor. Well, or you can either factor or you could just, remember we learned, so you don't even have to set it equal to 0, so let's erase that. Because we learned x equals negative b over 2a. So you get negative 5 over 2 times 1. So you get 5 over negative 1. So you get negative 5 over 2. Plug that in. So what that means that we're doing is y equals negative 5 over 2 squared minus 5 times negative 5 over 2 plus 1. What does that equal? So plug that in and calculate it. Make sure you do the negative because I almost had to double check that. So you get 29 over 4, which is 7.25. So if I did negative 2.5, so negative 2.5, and then 2, 4, 6, 7, so it goes up to 8, so it's just past halfway. So it's right about there. So if I go 2.5 back to enter the 0, I'm going to get 1. And then if I went 2.5 the other way, it would be just short. Or no, it would be right on. Right there. Hold on, that seems too far. I'd be at 5, negative 5, so there we go. So there, and it's dashed, so I make that one big one, and then, meaning no point on the line would work. Pick a point inside. If 0, 0 is available, plug it in. 0 greater than negative 0 squared minus 5 times 0 plus 1. Is 0 greater than 1? No. So the point we plugged in inside was false, so shade outside. Okay? So let's try another one. Are we doing dashed or solid? This is going to be solid. Set it equal as the equation. Okay. X equals negative b divided by 2a. So 3/4. Plug in your 3/4. And you get -1/8. Or negative 0.125. So if I go positive 3/4, it'd be right about there. If I plugged in 0 again, I get 1. So if I go to 1.5, I'd get 1. Solid line. See how the point 1, 1 is not inside the, or is inside the curve, so plug that in. 1 is less than or equal to 2 times 1 squared. So when you pick a number inside, this is what we do. We plug it in. Is 1 less than or equal to 0? No, it's false. So shade outside. Okay? That'll be the last time I plug the number in on this. So when I say plug it in to check your point that you're picking, this is what we do, okay? So press pause, try to graph it, try to set it up, try to do this one on your own, okay? So hopefully you press pause. So here we go. It's going to be dashed. Set it equal to, so I get -x squared plus 4x plus 2. X equals -b over 2a. Equals, not less than. I was trying to plug it back into the original. Plug in the 2 to get it. You get -4 plus 8 plus 2, 6. So I get the point 2, 6. If I plug in 0, I get 2. So if I plugged in 4, I'd get 2. It's a dashed line. So the point 0, 0 is not in there. If you plugged in 0, 0 and checked it, you'd get 0 is less than 2. Is that true? Yes. So it means shade the middle. Okay? Alright, let's try another one. So this says system. So the system, you need something to be true for both. So you got to graph each one separately. So if I look at it, the first thing, I know that's solid, and I know that one's going to be dashed. So the first one to graph, well, that should be an easy one to graph. The second one, well, let's see. X equals -0 divided by 2 times -1, so 0. And if you plug that in, you get 5, so 1, 2, 3, 4, be up here. If you plug in -1, you get -1 plus 5 is 4, so -1 was 4, so +1 will also be 4. Oh, So that one we have to make dashed. Because it was a dashed line, not a solid line. Okay. Now you got to test each one. So the 0.00 is not good. Not able to test for this one. So I'm going to put in the point x is 0, y is 1. So 0, 1. So if I plug that in, I would get 1 greater than or equal to 0. Is that true? Yes. So for that one, I would be shading inside. It was true. Use the same point for that. 1 is less than negative 0 squared plus 5. Is 1 less than 5? Yeah. So for that point, I would also shade inside. Now, where do they overlap? That's what you need. So where do they overlap at? Where they overlap is where you shade. So that is your final answer. See how I'm filling it in more? And I don't go outside the green or the red. So there's the system. Okay? Alright, solve the inequality algebraically and by graphing. So let's do it algebraic. We've done graphing for a while, so let's take a step because we'll do that second. Let's do it algebraically. So algebraically means just treat it like the equation. So you got to get it equal to 0. So you have less than or equal to 0. Now, see how it says less than? We'll talk about that in a minute. So see if you can factor. You do negative 3 times 2 is negative 6. So it's got to add, multiply negative 6 add to positive 5. So you would have 6 and 1. So if we say negative 6, positive 5, you have positive 6, negative 1. So I would have plus 3 minus 1. Less than or equal to 0. So think about it like an equation here. So 2x minus 1 equals 0, x plus 3 equals 0. Add the 1, divide by 2, so I get x equals 1/2. Minus 3, so I get x equals negative 3. So these are the zeros, and they're also values that are going to help us with the solution. See how it says less than? What that means is, see how I put the small one on the left, the larger one on the right, and the x in the middle? It means it's going to be an and statement because it says less than or equal to. Because it says less than or equal to right here, it's going to be an and statement like that. Negative 3 is less than or equal to x and less than or equal to 1/2. So one thing I can do here is go negative 3, so negative 1, negative 2, negative 3, and positive 1/2. So then what we just need to get now is the vertex. So x equals negative b over 2a. So you'd get negative 5/4. Plug that in. And you get negative 49/8, which is negative 6.125. So you'd have to go negative 5/4 is negative 1 1/4, so just past the negative 1, and then 1, 2, 3, 4, 5, so it'd have to be like down here, and it's a solid line. And see how the x is in the middle? If you test a point in the middle, it's going to be true, so still test it. So pick 0. Pick the point 0, 0. If I plug that in, just to remind you, is 0 less than or equal to 3? Yes. So this is true. There's your solution. But do you see how we solve it algebraically? So see how when it was less than or equal to, up here at the beginning. Now, you have to be careful because A has to be positive. Is A positive? Yes. That's when you know, since it's less than or equal to, that it's an AND statement. So let's look at the next one. Is A positive? Yes, it is. It's greater than. So instead of an AND statement, it's going to be an OR statement. And so let's see what that means. So first thing we got to do, subtract the 4 over. Factor, change it to the equation and factor. So you get 2x and 1x, and it's got to multiply to 8, negative 8, and add to 7. So negative 8 positive 1 because negative 7, so minus 4 plus 1. So I get 2x plus 1 equals 0. X minus 4 equals 0. Solve that, you get x equals negative 1/2. X equals 4. So what do we do? Because it's an OR statement. So you're going to have two different ones. So if you're not sure what you need to do, this is what you can do. Make a number line. Because to me it means this. X is less than negative 1/2. X is greater than 4. Because it's always going to be less than the smaller, greater than the bigger. But this is how you can check. Put those on a number line. Isn't that 0? Plug in 0 to the original equation. 2 times 0 squared minus 7, or inequality. Is 0 greater than 4? See how that was false? If you pick a number bigger than 4 and plug it in, it's going to be true. If you pick a number smaller than negative 1/2, plug it in, it's going to be true. See how those are true? That means x is greater. So there's the OR statement. Okay? These are a little confusing. You can always test on the number line just like I did. So if you have questions, ask them tomorrow. One more. A hammer is dropped from the top of a 500-foot tall building being constructed. The height of the hammer can be modeled by that equation. H equals negative 16 t squared plus 500, which is negative 16 t squared is gravity, where h is the height in feet, t is the time in seconds. Construction worker is busy on a floor that is 100 feet from the ground, sees the hammer fall. So it's falling from the top. Write an inequality that shows when the hammer is above the construction worker. Okay? So the height is above the construction worker. So you start with the original. How far off the ground was the construction worker? 100. So you got to subtract 100 feet of it, because that goes all the way to the ground. Plus 400. Okay. And then it says for what values. So when it says for what values, this is where you go 0 is greater than negative 16 t squared plus 400. Except we don't want the height to be greater than it. We want it to be above the hammer, or below the hammer, so we got to go the other way. So hold on a sec. This actually should have said less than, less than, less than. So now if I subtract it, I get negative 400 is less than negative 16 t squared. Divide by negative 16. Now, remember when you divide by negative, you got to switch it. So you get t squared is less than, and then 400 divided by 16, or negative 400 divided by negative 16, 25. Take the square root, you get t is less than 5. Why not positive or negative? Because it's seconds. You can't have negative 5 seconds. So Remember what I said about this being the inequality being the time, or being an and statement? Well, you have to start at 0 because you would say -5 positive, but 0 is less than t, which is less than 5. So anywhere between 0 and 5 seconds. And that one can equal it because you can equal 0. It's got to be less than 5 because at 5 seconds it would be at your height, not less than. Okay? All right, guys, be ready for class tomorrow.